although special relativity states that there is no preferred inertial frame of reference in space with which to compare the Milky Way. The Milky Way does have a velocity with respect to cosmological frames of reference. One such frame of reference is the Hubble flow, the apparent motions of galaxy clusters due to the expansion of space. Individual galaxies, including the Milky Way, have peculiar velocities relative to the average flow. Thus, to compare the Milky Way to the Hubble flow, one must consider a volume large enough so that the expansion of the universe dominates over local random motions. A large enough volume means that the mean motion of galaxies within this volume is equal to the Hubble flow. Astronomers believe the Milky Way is moving at approximately 630 km per second, 1,400,000 miles per hour. With respect to this local co-moving frame of reference, the Milky Way is moving in the general direction of the Great Attractor and other galaxy clusters, including the Shapley Supercluster. Behind it, the local group, a cluster of gravitationally bound galaxies containing, among others, the Milky Way and the Andromeda Galaxy, is part of a supercluster called the local supercluster, centered near the Virgo cluster. Although they are moving away from each other at 967 km per second, 2,160,000 miles per hour, as part of the Hubble flow, this velocity is less than would be expected given the 16.8 million% distance due to the gravitational attraction between the local group and the Virgo cluster. Another reference frame is provided by the cosmic microwave background, CMB, in which the CMB temperature is least distorted by Doppler shift. Zero dipole moment. The Milky Way is moving at 552 plus or minus 6 km per second, 1,235,000 plus or minus 13,000 miles per hour. With respect to this frame, toward 10.5 right ascension, minus 24 degrees declination, J2000 epoch, near the center of Hydra, this motion is observed by satellites such as the Cosmic Background Explorer, COBE, and the Wilkinson Microwave Anisotropy Probe, WMAP, as a dipole contribution to the CMB. As photons in equilibrium in the CMB frame get blue shifted in the direction of the motion and red shifted in the opposite direction,